Solving rational equations, example 1. We've been working with rational expressions for a long time, but now these are equations, which means there's an equal sign. However, the techniques are still the same. We're going to have fractions, 1/12 plus 1 over y, but now the twist is that there's an equal sign, 1 over 4. So we need to solve this using algebra. However, these fractions are not cut into equal pieces. One's cut into twelfths, one's cut into y, and one's cut into 4. So like we've been working with, we need a least common denominator for all three. What number does 12 and 4 have in common? 12. And what is the variable that needs to be included to make sure everything is evenly divisible? Y. So we need to turn each of these into 12y. So I'm going to rewrite this. And the question is, as always, what do you multiply the first one by to make 12 into 12y? Y over y. So 1 times y makes y on top, and we're done. What do you multiply 1 over y by to make 12y? 12 over 12. 1 times 12 is 12, and that's done. Finally, what do we multiply 4 by to make 12y? 3y over 3y. 3y times 1, 3y. So at this point, if you'll notice, every denominator is the same, which means every part is cut into equal pieces. The beautiful thing about this technique now is that you can ignore the bottoms and simply work with the tops, because all the tops are cut into equal size pieces. From here on, it's straight algebra. Let's solve for y. Collect all the y's on one side. 12 equals 2y. Divide both sides by 2. Y equals 6. Now with these, there's one thing we have to check. We always have to look at our excluded values. If we come over here and look to see what our excluded values might be, 12 times what number makes 0? Y cannot equal 0. So we need to always check to make sure that our answer that we think is right is not one of the excluded values. It is not, so we are done. Solving rational equations, example 2. Let's try 1 over 6 plus 1 over 12 equals 1 over m. Anytime we're working with fractions, it's important that they're cut in the same size pieces, which means the denominators need to be the same. So like we've been working with for quite a while, what's the least common denominator we could use? If you look at the numbers, what's in common between 6 and 12? 12. And what about the m? We have to include every variable so that everything divides evenly into it. So our common denominator is 12m. Well, let's see what we need to do to make that happen. What do we multiply 6 by to make it 12m? 2m on the top and the bottom. What can we multiply 12 by to make it 12m? M on the top, m on the bottom. What can we multiply 1 over m by to make it 12m? Multiply by 12 on the top and 12 on the bottom. So let's do that and write down what's left. 2m times 1 is 2m over 12m plus m times 1 is m over 12m equal sign. 12 times 1 is 12 over 12m. Now it's important at this point to realize you don't want to start factoring and canceling. What you want to do is notice that the bottoms are all the same. The denominators are all the same. That means that everything is cut into equal sized pieces. The technique is now you get to ignore the bottom. You can rewrite this paying attention only to the tops and solve. So let's finish this up. 2m plus m makes 3m equals 12. Divide both sides by 3, m equals 4. Once again, before we're done, we need to check for extraneous values or excluded values. Either one is appropriate. Back up here, m cannot equal 0. Our solution is m equals 4, which means that we've solved it and we are done.